Now, picture this. Lasers fired from space scanning the entire planet in 3D down to the meter. That's the goal of a new San Diego-led NASA mission, and it's set to launch around 2030. I take a look at how it could transform the way that we track climate change. Picture this, a powerful laser system in space scanning Earth over and over again. That's exactly what a team here at Scripps Institution of Oceanography is building after being chosen by NASA to lead an entire satellite mission. It's called Earth Dynamics Geodetic Explorer, EDGE for short, and it marks the very first time that NASA has chosen UC San Diego to lead a satellite mission.
Just by simply tracking height, you can actually get a really good handle on the state of the Earth and what's happening with it, how it's changing.
Helen Amanda Fricker is a professor of geophysics at Scripps and is leading the mission years in the making.
Gratitude that we were selected because this was a big deal, a big project. We had a lot at stake, to be selected on, and just what an incredible achievement.
Getting here wasn't easy. Her team's proposal was one of 4 finalists.
Of the 4 missions that went forward in step 2, only 2 of them could get selected. And so, of course, we knew we only had a 50% chance.
EDGE was ultimately chosen with a target launch date of 2030 and a major NASA review for 2027. So what will it actually do? The satellite sends laser pulse down to Earth. The light hits the ground, trees, or ice, then bounces back. Scientists measure how long that takes, and from that data, they can calculate height with incredible precision.
What that does is it just gives an incredible amount of spatial coverage every time the satellite orbits the Earth, so that we just cover the Earth with so many LiDAR points, which is basically tracking 3-dimensional height of the Earth's surface.
And it's not just one laser, it's 5 split into 8 separate beams. And unlike earlier missions that scanned in narrow tracks, EDGE will provide broader coverage in more detail than ever before.
We're actually tracking vital signs of Earth, just like a person sort of determining their the physical state. You map temperature, blood pressure, all these different parameters that you can map with the Earth.
With data that could be critical.
For example, if you have a forest fire, you sample it before the fire, you know how much biomass, how much carbon there was stored. You go again after the fire, and you can get a very, very accurate measurement of how much was lost during that fire.
Better measurements mean better decisions, from disaster response to water planning, transportation, and environmental policy. And for Fricker and her team, that payoff is clear.
Information is power for us. Living on the planet, we need to understand how our planet is changing and evolving. We get that over very small areas from aircraft surveys with LiDAR, but we don't get it systematically. And so the satellite will give us that information that we need.
The mission, born right here in San Diego, could deliver the most detailed 3D map of Earth ever created. I totally geeked out when I was covering that story. Well, if you'd like to see more of our Earth 8 reports, you can stream them now on our app. Just download it for free on your TV or your mobile device.